we have a question about probability. So the question's asking, what's the probability that a coffee shop runs out of blueberry muffins by the time Sarah finishes her shift? And it's 0.25. So the probability of no muffins. So no muffins, I'll just say it like this, or you can write it like this with a line across the top to say that it's the opposite. It's not. And that is equal to a quarter. All right. And there's also some more information that says Sarah calls in every Tuesday to buy a blueberry muffin on her way to her morning yoga class. So what is the probability that on the next 7 Tuesdays, Sarah manages to buy a blueberry muffin each time? All right. So uh, this one is we've got 7 trials. So the amount of times we're doing this is 7 times. And the probability of success, the probability that she's able to get her muffin is the opposite. So that's the probability of getting a muffin. All right, and now you might have seen this equation before. 1 minus the opposite. So that's just saying that we're given it's a quarter chance that there's no muffins. But if we find the opposite of that, that's 1 minus a quarter. Okay, and so that would be equal to 3/4. Now this is a binomial problem. So we can say it's binomial and there's 7 shots and they're each 3/4. So you can either do this with the formula, but it is calculator assumed. So what we can do is just say it is 3 divided by 4 all to the power of 7. Okay? And when we do that, when we calculate that, okay, so we will have 3 divided by 4 all to the power of 7. Okay, that gives us this horrible thing. So let's convert that to a decimal. So 13% chance. Okay, so we've got a 0.1334, and so the probability is going to be equal to 13.3%. Okay, so that's the first part. The next part is asking, what about on the next 7 times that Sarah goes to get a muffin? What's the probability that she gets a muffin 5 out of 7 times? Okay, so what's the probability, right, that she has 5 successes out of 7? All right, so what we can say is the probability, right, that x is equal to 5, all right, and then we can just put that into our binomial expression. So x being the variable that describes whether or not she gets a muffin or not. Let's just use the calculator. There is a formula that you can use, but we can just use our calculator, which is going to be much easier. So if we go to interactive and we go to distribution, and it is discrete, and it is a binomial PDF. Okay, so how many trials? There's 7 of them. Sorry, let me just be 1 second here. So there's 7 trials, and there's going to be 5 successes. And so working that out, go discrete, and we want 5 of them to be successful. We want 7 of them there, and the probability of success is 0.75. So if we write that in, we get that it is equal to 0.311. So to write this in, right, you can go bin PDF and just write it in here. So 5, 7, and 3 divided by 4. And then what you can say is use calc. All right. Just tell the marker you are using a calculator, and that the probability of x is equal to 5 is now 31.2%. Okay, and there's your answer. Okay, so the next question, part C, is asking Sarah can buy a blueberry muffin on the last 4 Tuesdays, given that the shop had run out. So it's like, so what's the probability that Sarah can buy a blueberry muffin if on the last 4 Tuesdays the shop had run out of muffins? Well, this is just to show that they're independent. So every week it's independent. So really we can say it's just always going to be 3 and 4 because they're independent events. So what happens one day doesn't affect the next day. So in this case, it's equal to 75%. The next question is saying on the next 7 Tuesdays, Sarah is able to buy a blueberry muffin only on alternate Tuesdays. So what's the probability that on the next 7 Tuesdays, Sarah is able to buy a muffin on alternate Tuesdays? So that means that it's so yes, no, yes, no, yes, no. What is it? 1, 2, 3. 1, 2, 3, 4, 5, 6. And then we need another one, 7. Or it can be this way. So we've got 2 sequences that we can use. Okay. And so I guess what we're wanting to say is that there is this first sequence here, and that is like one case. So we can say that there are 1, 2, 3, 4 chances of success in the first case. So we would say that it's 3 to the power of, or 3 divided by 4 to the power of 4 times by the opposite, and that's equal to 3. So hopefully you can see that these numbers here correspond to these ones. All right, now it's or, so we've got the first line, or she can have 3 yeses and 4 no's. So when or in probability normally means plus for independent events. Okay, so let's use our calculator here. So we'll just say use calc, let the marker know what we're doing, and let's come across our answer here. So I'm just going to quickly put it in. I've got a keyboard here which makes it a little bit easier for me. I know you don't have that, so it takes a little bit longer. But I'll put in my equation in here. And just make sure that looks all right. Yep, and that's our answer in here. So in this case, the probability is equal to 0.0133 ... And let's just round it to a couple of significant figures. So we can say times by 100, and that gets at us in 1%. So we can say that is equal to 1.34% chance. So hopefully that makes sense. It's about using the binomial function here. That's really important. And then also just using the calculator to crunch numbers for you is also really important as well. And specifically this function here. That's going to be super useful in the questions to come.